String here. Wait. Yeah. So, I guess I'll just read it. Yeah, if someone wants to say something, just unmute and talk or write on the chat. I'll try to look at the chat, but I might see. So the thing, the thing we were going to look at today is this, instead of a paper, is this circuit research landscape thing that is on the Neuropedia page. And it seems to be like a summary of all of the new, all the state of the art in this kind of interpretability research. And yeah, I haven't read it yet, but yeah, we can look at it. First, so it has a bunch of mostly just right. Yeah. Okay. I guess I can just read it all out. It's helpful to draw an analogy between understanding AI models and biology. AI models like living organisms are complex. Yeah, this is just saying why interpretability is nice. We might want to make predictions about unexpected behaviors or new capabilities that might surface in development. And we would like to debug known issues with models such that we can address them with appropriate interventions. Achieving these goals, we expect will involve a patchwork of conceptual models and tools operating at different levels as in biology. Yeah, that makes sense. Okay. So, okay, so the value of behavioral observation. The analysis of behaviors, there's also much understanding about how they work. For instance, for behavioral experiments in how encounters learning, general thought, whatever, how to encounters learning, and define the misalignment. Yeah, there's a bunch of text papers, some of which we probably have, some of which I think we see on the reading group, but others are not. Yeah. This one is thought in faithfulness. The first one is just a problem. Oh, sorry, it's the same one. A lot of context reasoning. A lot of cool. A lot of the cool like research into this kind of behavioral research is from Owain Evans and his math students too. Like, yeah. But it's also the alignment faking thing. And what's this? Yeah, this is another 1.7 paper. Yeah. I feel like this thing, I think this is interesting and related in the terms of trying to understand language models, but the things, I feel like this is the things on that this first section are not what I would call mechanistic interpretability. They are more like, it feels like it's kind of a related but different field. Okay. Okay, this is just trying to make a narrative thing because now it says the value of modeling kernel, so I guess they just mentioned the first thing to contrast that. Yeah, feel free to interrupt me at any point to say something. Okay. Sometimes horrible behavior observations leave us with questions that is difficult to resolve without looking inside the system. What general knowledge of character traits do model learn from specific data we don't know? The more is truly plan or convincingly fake it, and so what kinds of plans they can represent. When models display undesirable behaviors like reward hacking or jailbreak hallucinations, do they know they're being naughty? Do we clear answer questions like this, we need ways of looking at the representations and computations in the model. Yeah, that makes sense. This feels. Yeah, this seems like a weird, like, list of things where it feels like more like like it's a text written about like first they talk about this. It's not like the things are independent. It's more like it's just a big line of text that was dividing a bunch of points for some reason. Anyway, probably there are two approaches to study model internals. Yes, this supervised and unsupervised. There's nothing. It's just but yeah. We know what supervised and unsupervised is.
What is the difference between supervised and unsupervised methods?
Oh yeah, I can say this one. I just thought that a lot of people. Yeah, it's a very common thing. So supervised method. I guess probably a different way to say it here. Supervised is when you yeah, I think there's a good explanation. Supervised method there's a specific hypothesis and supervised methods generate hypothesis. Like supervised methods is when you have some idea, like for example, probing, you think that the model has a representation of some specific context, sorry, for some specific concept or something, like I don't know, dogs. And you try to find how the model recognizes that context, or if the model can store that context of part of the model by like manually labeling that data or something like that. And in supervised methods are things like Sparta or something. You try to aggregate the data in some way to find patterns. Like in particular, you are trying to take the activations and divide them in some set of spans, like some set of directions on the model that can individually mean something, but you don't have to know what the concepts represented those iterations are. The suppose just place about the iterations and later you try to figure out what they are.
So things like activation patching and so on, they will also be unsupervised because we don't know exactly what activations mean before we start experimenting.
I feel like also in the activation patching, I think this it feels like this distinction is not super clear in something like activation patching. You could say that activation patching is like it's supervised because you have some specific example that you care about. I don't know. I think people here are making some analogy to like supervised and unsupervising machine learning in general. Like so, it makes more sense in things like probing and expression codes where you're training something, and in something like activation patching, I don't know how they will divide it here.
Okay.
Maybe this is the past, yeah, observation. Yeah, I guess the way they are describing it here, they will call. I will guess they will call activation patching supervise. In that you are. I don't know. I guess it depends on context. Maybe they mention that later and call it supervised or unsupervised, but we see. For studying model representations, linear probes are a natural supervised approach, testing for linear representations of a particular concept of interest. Yeah, that was the same. The linear probes is like the example of supervised, but also it's just supervised learning in the usual sense of like the machine learning. So probes has been used to identify representations of honesty and harmlessness, space-time coordinate states, and host of other constraint models. Yeah. Expression encoders and red methods are supervised alternative, capable of imperfectly surfacing many concepts represented by the model without specifying them in advance. Expression encoders have been applied to supervised interpreters. Yeah, this is just. Okay. Okay, the composition computation is about how, that once you have some set of representations, you want to try to find how the model is using those representations. And so people are trying to find things like circuits of combinations of representations. Like see what I mentioned, things like the model, this thing where there was the thermal paper where they figured out that addition to the models, I think it was GPT-2. Yeah, they found this algorithm that the model uses to do addition that is kind of related to the one in the modular addition thing that Neil did, but this is just for addition in general and some big language model. I think it was just GPT-2, so it's not that big, but yeah. It's GPT, yeah, and Python. And yeah, there's also this entity binary thing. So these papers, these papers are basically people manually figure out how some specific part of models works. They have some concept and they did a bunch of things like probing to figure out and doing activation patching and things like that.
I have a question. So it appears that linear probes are for the supervised approach, and sparse autoencoders are for the unsupervised approach. These are relatively new terms to me. Kind of trying to get to grips right now with how you would, for example, go into a model, use a sparse autoencoder approach to kind of get an idea of possible hypotheses and use linear probes to test them. I'm not sure.
Okay, so I don't know if you know how sparse encoders work.
I don't.
Okay, so when the sparse encoders are basically you take some activations of the model, right? And they come in a lot of text, and you train an autoencoder that you just put on the middle of the model, and the autoencoder has to learn to represent and has some sparsity penalty, or like something simple people do is just do a top K sparse encoder, where you pick the top whatever, top 10 or something most activated neurons, and so you basically want this person encoder to learn some compressed representation of the activations that has a bunch of subcomponents. Like you have the activation, which is a big vector, and this person encoder is trying to learn some compressed representation of that, where it has a bunch of individually activating components that somehow summarize the person encoder has to put the activation of the model to that compressed representation and then reconstruct the original, so it has to learn to compress the information accurately there. So you get these sparse encoder latents, and people find that you find that they usually mean things, and sometimes they even you can have them individually meanings. You have to find some sparse encoder representation that I don't know, some dog direction or something, and you find that it activates. You have some random sparse encoder activation, and it turns out that you look at the text that it activates on, and it seems to be talking about dogs or something, or English text or something like that. And yeah, that's why it's unsupervised. You don't have some idea of what the model is representing. You just try to do something like compression on the model and find.
Maybe I misunderstood what you were saying, but it sounded like you were saying that you were activating a part of a neuron of the neural network, and it was activating dog. But I might be mistaken.
So you have a person encoder.
That sounds supervised. Sorry.
So no, you have this person encoder, right, that has been trained and has a bunch of latents that it just learned, right, that somehow represent the same activations on some part of the model, but they represent with some nice properties like sparsity, where, for example, only a few you make it so only a few activations or a few neurons of the sports encoder activate for some text. So you end with different parts of the sports encoder, like different laters of the sports encoder meaning things. But you later look at them and figure out what they mean by looking at which text they activate. You don't manually make them.
Okay, so it sounds like there's a little bit of supervision going on, because you have to know what,
Like the sports encoder itself doesn't require supervision. You just train it on random text, and it just compresses the activation.
It's like training another layer that has more neurons or features, so you're able to look at it a lot better than the superposition inside the neurons.
Makes sense.
Yeah, and then probing people usually.
The way I visualize it is probably something similar to the tunnel where you go in, you become bigger, and then you go through another tunnel and you go smaller. So that in between where it's bigger is the activations you're actually modifying with the SE. Maybe that's a bad analogy.
Yeah, I think that makes sense. Could also be smaller, but yeah.
Yeah, but most of the time it's for making it bigger, unless you're that's just an autoencoder if you're, I guess.
I mean, normally when people do autoencoders in other contexts, they want to make them smaller. But in sparse encoders, it can work with bigger. because you have the sparsity, and so it's someone is writing text. Anyway, and for the probes, people use them. Probes is just training a classifier on the activations of the network for some labels that you want. I mean, it's just the usual definition of supervised and versus unsupervised learning. That on machine learning is just that people in this context, people are talking about you have the activations of the model and you want to understand them, so you are doing machine learning stuff to them, so you can do use unsupervised methods, which is basically person calls, or you can do supervised methods, which is just the typical do a linear classifier on it for some labels, which is that people call linear probing. Oh, so someone asked, do you know of any methods by which the sparse encoder feature labels were made by a human rather than by other? So yeah, there are methods to use LLMs to label them. And you can also have people manually look at the things and figure out what they do. Like this page, Neuropedia has a nice thing where you can go to examples of features here. Like you select a model and you select some random feature, and you get you can set for activation, but you get some text where it activates some or a bunch of features that activate some different text, and you can try to figure out what it does, and there is a here you can try to figure out what it does and write an explanation. There is, I don't remember where it's it, but yeah, there is something you can write an explanation for it, and people can then say if they think it's correct or not, and you get. And there is also automatically generated ones. But yeah, there is a lot of features, so it's easier to just use auto label thing with just basically just ask ChatGPT to label the thing based on examples. There is a nice method to score the both human and LLM generated explanations, which is you take a LLM and you ask the LLM how, like, if some text matches, like which parts of a text matches, to try to get a LLM to predict the activations in text that you didn't see. And that if that matches, then that should be a good explanation. But yeah, to generate explanations, the current best method is just people manually doing it. But there is a lot of different activations, and it's very hard for people to figure out all of them. And I mean, European tried doing a nice interactive game thing, and maybe that didn't get very popular. I mean, it would have been funny if that was people like that, and there was a lot of fun people helping doing that just to get points in the game thing or something. I don't know if it's working now anymore, but yeah. But it's just, I think, last time I saw data, it was still worse than humans. Maybe GPT-5 is better. I don't know. I remember when the original auto labeling thing came out from OpenAI. They said the LLMs were much worse than humans. But that was a while ago, and now the LLMs are better, so I don't know how much better they are now. Anyway. Let's go back to this. Yeah, so linear probes. People use linear probes more to. You have some idea about. You think the model represents some concept, like I don't know that there is a checkmate in some position in a chess model, and you try to see if you can, for some part of the model, predict using a classifier from the activations there the the thing you care about. You have some label data and you want to see if you can, from the activations of the model on that data, figure out if the whatever concept you care about is on that input in that data, and that way you can see if you are doing a linear probe, for example, you can see that there is some linear representation of the thing you care about in that position. Of course, that won't tell you if the representation is not linear, but a lot of things are linearly represented in LLMs. There is a problem if you do a very overcomplicated probe with a lot of steps. There is a problem where you might be like your probe might be doing the whatever operation you thought the model might be doing. Like maybe the model doesn't know whether it's a checkmate on that position, and your probe is actually calculated in from other information that the model has already. So that's a reason people mostly use linear probes, or only slightly more complicated than linear probes. Anyway. Yeah, probes have been used to identify the percentage of honesty and harmlessness, space-time coordinates, game states. Is the game states? No. Oh yeah, this is the a big example is this paper. Yeah, also someone like super stealthy ship wrote a long thing explaining sports encoders. But yeah, anyway, while going back to this, so this paper is originally this was a blog post by Neil that he did in a weekend, but I guess they made a paper. This example, well, they have this model that was trained on Ortello, where it just the model doesn't actually get the board as an input, it just gets the list of moves, but it learns they found there was a linear representation of the board state inside it. There was a previous paper that said that there was some weird nonlinear representation, but it turns out they were probing for the wrong thing, as it says here, because they had to, like, they were looking for a representation of white versus black, and it was a representation of your color versus the opponent color, which makes sense. Once you figure that out, you can do probe for where pieces are, like for if some square has a piece, and you get a nice representation. Like there is some nice linear representation. Yeah, there's also this thing, which is I feel like I probably next time I need ideas for reading groups, I need to just go back to this and see which ones we haven't done. I don't think I don't remember this one exactly. But yeah, you can probe for things like honesty. There's also this another one from Denmark. It was this one. They were trying to see model, like I think they ask, yeah. Okay, they have names of places and they find that models have like some internal representation of where those places are. Makes sense. There's a bunch of other related stuff to that. Like I remember someone making a map by asking a model, like a map of the world, by asking a model if there was land on some position. Yeah. Anyway. Also, the seems somewhat analogous to PCA. Yeah, it's the same kind of thing. Like PCA is also like in the typical machine learning stuff. The people just call PCA as unsupervised methods too. Anyway. Yeah. Computation. Yeah, going back to this. So once you have the model and you can use something like sparse encoders to divide them. You want to divide them in individually meaningful components, because if you say, okay, let's pick the neurons of the model and see what each neuron means, that doesn't work. Like the models, there are some working superposition where shows that like neurons are not the correct units analysis to look at the model, because you have a lot of concepts are represented as some linear combination of them. So that's why people came up with the sparse encoders. But once you have, and there is a bunch of work in trying to get better methods to decompose models, because sparse encoders are nice, but they don't work that well. There is another post by Deepmind, basically talking about that, about how they didn't find a lot of things where doing some sparse encoder kind of thing work out better than something supervised like probing. People have come up with a lot of variants and better options. Now, I think the thing people use these days is transcoders, which are a variant. But yeah, there is a lot of work in trying to decompose the models better. But once you decompose the model, you want to figure out, as the decomposing computations, you combine how you get from one of those from one representation to another, and like how is the model doing computations and all that. And for that, people do things like there is these papers that I mentioned before where they figure out things like validation. That kind of thing is usually they did it mostly by manually reverse engineering things. I also published a paper like that. When you have some tiny model or some small quarter of a meter model, and you spend a lot of time doing interventions, maybe you have some hypotheses, you ablate different parts of the model, see which ones actually matter for the output and things like that, and so on, until you figure out how the model, like you have a clear idea of how the model does the thing you care about, or how the model works in general if you're doing a very tiny model, but that doesn't scale other things. Here they talk about scale. Recently, computing attributions between features from sparse encoders or transcoders after a prompt has a Mech supervised approach to the problem. Okay, so they talk about this attribution. Yeah, I don't know that much about the attribution graph stuff. Oh yeah, no, this is the thing from the Anthropic paper. Yeah, I remember now. Yeah, we read this at some preview reading group. Yeah, no, I remember. They had this automated way of saying like which representations came from previous representations and so on. That's why they make these nice graphs. There is like it's on like I think it's recorded on YouTube. Like if you haven't seen, want to see or like our previous talk about this. Yeah. Attribution graphs present a feature interactions on a particular problem with the graph. Graphs of statistical hypotheses will can be validated and refined using intervention experiments supervised methods. There's more supervised characterize the method and follow on the work, including appropriate Yeah, before that, people were doing things like ACDC, and there's a bunch of other methods with work, something like you do a bunch of automatic operations or patching to try to figure out how you do a bunch of automatic patching to try to get a graph like this. This attribution graph thing is from a more recent post by Anthropic, and it's better, I guess. I feel like there is a problem where we like if we want to figure out like good ways of reverse engineering the circuits on the models like that. Like on the end, you want to have some kind of graph between some kind of representations that individually mean things, such that when you have a graph of how they connect, you more or less understand what the model is doing, and that you both need better methods to make like these attribution graph things to get the graphs, but you also need to get the sparse autoencoders part, like the composition correct. Because otherwise, you are not going to. If you do it on Neuros or whatever, you are not going to get something super sensical. There is a dual problem of like you have to do the both fix those things at the same time. Yeah, so that's why like parts of the like the compositions are not that good yet. Like they are getting better. But there is a bunch of problems with the compositions. Anyway. On course to biology, Mech Interp has historically focused on developing more principled methods for understanding models. Existing microscopes, when pairs and supers to answer many important questions. Mechanisms inside that for the yeah, this is true. Like we don't. It doesn't. People are still work still working better methods which they talk about like it's like building better microscopes or whatever. But you can already with the circuit tracing post, they already found a bunch of, they have a separate post where they find a bunch of interesting interesting mechanisms on the model, and there is probably a lot of work to be done on people using this kind of method to spend a lot of time looking at some large language model and finding different how different parts of it work. It's still kind of noisy because the methods have problems. But yeah, the Anthropic thing already found a bunch of things. Okay, attribution class for study model biology. I probably experimented this better here. Yeah. The attribution class method has been implemented by groups. Yeah, there is this library that is open source and does the same thing. On some open source model because the original thing is by Anthropic on cloud, and that you can't replicate that directly because you will need the model. Okay, so EleutherAI release. Oh, okay, apparently EleutherAI also release a separate attribution graph library. Nice. Yeah, I didn't know about. I wanted to read this because I didn't know about all of the things people have in it. Okay. Suppose cross-layer transcoders, Goodfire also internally. Okay, so yeah, Goodfire also did this, but it's not a library. It's just they internally did that.
For circuit tracing.
Oh, this is this is for attribution. I mean, is it
I loaded an
that-
attribution graph before. I could show you one of mine later. if you want.
wait, is it the attribution graph thing you get
Why did
from
it stop? Oh, because it went over.
Graph for Quen 14b.
Sorry, Cinema, I didn't hear whatever you said.
Oh, sorry, that was a mistake. I think someone else said something about where it was.
Yeah, so what's saying?
Yeah, to make attribution graphs, you just need the transcoders, which you could find from the Anthropic fellows. I think they have like a bunch of transcoders they made for them. And then all you have to do is get the transcoder and get the base model that has a similar architecture, and then you could run circuit tracer on it. When I was doing it for Quen 14b, which was a 14b parameter model, I think I needed an H200 too. And since circuit tracer is all in transformer lens, I recommend using one strong GPU, since it seems to not be able to run the processes in different GPUs at the same time.
Yeah. So you can use basically if you want to do this kind of thing, you can use the
there's an alternative like EleutherAI attribute.
Yeah,
really
the attribute one. Yeah. It shows both.
I think the EleutherAI one is probably better since it, but I haven't tested it yet.
Anyway. Yeah, no idea. I haven't tried any either. Okay. Let's see what else this thing says. There's applications are reproduced on the they reproduce the original paper. I guess they have some samples. Show that giving inputs like they have this Gemma2 model. Inputs like the state containing Dallas has its capital in, okay, and Gemma2 activates Texas features and then activates say Austin features. Liquid tracing allows us to see that this intermediate hop was used in addition to shortcut paths when study for Dallas and Austin. Yeah, this is very similar to the Anthropic thing. So basically, when you say when it says capital of the state, the capital of the state containing Dallas is there is a say a capital city feature that gets combined with Texas to say and outputs out this thing. But when the model outputs a thing, it doesn't only has some specific saying of like single thing it does. It's also doing a bunch of heuristics, like when the Texas show it like anytime in case it needs and things like that. And also like saying Texas makes saying Austin most likely and things like that. So for even on all of the Anthropic samples, you see that there is a bunch of different shortcuts and stuff and heuristics that the model is always using in combination with the actual thing, more principle thing it does, which is have some mechanism where it has some.
Victor, did you find a way to get the supernodes to work with that attribution graph from circuit tracer?
Haven't used a circuit tracer yet, so no idea.
I don't think they have the supernodes by default. I think you have to
say again.
enable it. The supernodes are not a default feature of attribute library, so I'm not sure how to actually generate.
Yeah, the supernodes you manually build, like it's a manual annotation process.
I wasn't able to do it when I tried doing the neural app, I couldn't really get it to work.
Oh, like it wasn't supported even to add supernodes?
No, I just didn't know how to make them. Couldn't find the library to make them.
Yeah, I think somewhere in the repo there's a tutorial notebook where they show you how to make supernodes. I think just from
how to use it from Neuronpedia, and they show how to do the tracing, but they didn't really show how to make the supernode graph from a new model. So unless I wanted to use like Gemini 3 in the 2.5, I couldn't really do it.
They had some video on YouTube, and it seemed like they were doing it mostly manually.
Yeah, the supernodes you make manually, like you have the attribution graph, which is just nodes, which are like SAE features, and then you manually merge them into supernodes.
Basically, you have to select the nodes that seem interesting, like they have like some interesting interpretable features, and then you just have to drag and drop on top of each other, and they just merge into a supernode, and then you can label them, use it in a circuit.
Oh,
yeah,
so
it's a
this
totally
video,
manual
right?
process. Yeah, both of them show physics.
I'll just post the Neuropedia channel of the.
Yeah, I think it's the part 2 that they do and it didn't seem like
they had
a real
a video
process.
on how to use attribution graphs from the Neuronpedia. I didn't think of looking at YouTube. That's
Yeah.
Yeah, I also didn't know they have a YouTube channel, but it's
I
nice to know.
don't like how most of this information's in the videos, like thought anchors. Like some things were in the video, like the slide point presentation that was never shown outside in the paper or lesson.
I mean,
It's crazy how there's so much information in the video.
maybe you can take the information in videos and write some explanation somewhere as a blog post or something for future people, to help future people who have the same problem as you.
Yeah,
But,
and I don't know if anyone actually saw this part too, but it really did not seem like a trivial process, and the person like kind of presenting had a hard time kind of engineering it like from scratch for the video, and instead kind of gave up, I think, like 10 minutes through and just was like, okay, let's look at the
That's
already
actually
created
it's-
example. So it
That seems
takes
like
like
it's
quite a bit
maybe,
of time.
badly designed. Well, I think that it might be hard if you want to have to figure out the actual how the model work, like how the are trying to figure out what the things mean manually on the video. That's probably hard. Like, there's no way of making that nicer because that's a problem. Like maybe there is some automated method you could do with some LLM doing the supernodes for you, but that has the same problems because there is no nice way of telling that, like no nice ground truth like in the labeling thing.
I think in the circuit tracing paper that I guess came out in like, was it May or something? They mentioned like, oh yes, it would be nice to automate this. However, it's very like it ends up being very manual because like it's like a complicated process,
Yeah.
and it seems like there's not a straightforward just procedure, just do it.
Because
Yeah.
you want some summary that people can understand, and there is no nice ground truth for that, like there is for like. I really like the method for the labeling of sparse encoder features where you use the sparse and like use a large language model to check if your explanation matches. And maybe there is something you can do related to that, but it's not as obvious as that. Anyway, features that okay, so features that track clause boundaries. Yeah, as from the chat, I think this page is kind of an attempt by them to try to put all of these papers and stuff on the same page. It's probably going to be obsolete in a like. I guess maybe it would be nice if there was a thing where that everyone can contribute to, and there is like that everyone agrees to use the same thing. Is probably the harder coordination problem here. So this won't be outdated in a few months. Like I don't know, maybe you could make a wiki or something. But yeah.
Yeah, I think there should be like some active effort to try and automating the creation of supernodes at least.
Yeah, that's another thing, but
I think in a related work they talk a bit about trying to automate things too, or not related work, directions for future work. There's some interesting stuff
wouldn't
in
be
there.
surprised if like Anthropic just solves it in like a few months. There is a paper and some of their very long posts in their webpage. They just have some nice method to automate it with cloth or whatever. It feels like it kind of has to involve having a large language model, like in some sense, it's a task that requires some kind of common sense understanding of the of what is going on there and translating that into text, and that feels like has to involve some language models, making sure that the explanation is actually, in some sense, like the subdivisions are in some sense correct or something. Anyway. Okay, so features that track boundaries. So okay, so this is demo thing. Yeah, maybe it would be nice. I don't know if in Europe in all generate example, like you can put examples or something of some, doing this kind of circuit, like distribution graph or whatever with the neurons. Oh, maybe they have something here on the circuit tracing part. Yeah, nice. Yeah, okay, so you can. So it is already on Europedia. And you can generate new graphs or whatever. So at least for this, for the having graphs or complete examples of graphs, I guess there is already a specific repository for it. It's just Neuropedia, apparently. I think I might look at this later and see what. Though, can you? Oh yeah, so anyone can contribute to it. It seems like so far all of them are just from the same person and nobody has. Oh, these are the featured ones. Okay.
It's crazy how people actually manage to
makes
manually
sense for
annotate
others.
it for even like the small models, but the other models, there's no way to really do it. Label
Yeah.
them.
Feel free to just go here and try looking at some, like try making one of these.
I couldn't figure out how to upload my attribution graph onto Neuronpedia though. There's something on the doc, I just couldn't figure out how to do it with Quen14b. Since it wasn't in the list
I
of
feel like you
models.
can also make attribution graphs here on this.
No, only for those
Yeah.
two models. It's only for the two models that you.
Okay. Yeah, that's sad. But yeah. Anyway, let's go back to the thing. So feature characters properties. Feature decide between readings of fragments, like because the suspect changed the file. What it might be that the suspect is the subject or the direct object. Yeah, this is like the what it was called. There was a name for this kind of ambiguous sentence that used to be a problem in AI, and there was a thing about how it requires common sense or whatever. I know it's the same thing, but there are something related to that. I'm blanking on the right now, but anyway. Models have features that track letter-level properties of individual tokens. This is especially, but not exclusively, the case in circumstances where the spelling of phonetics of the word is salient. This is interesting because the model is not trained on letters, so it has to learn in convoluted ways what this kind of feature. Or like maybe the letters are spelled out or something. But by default the models are trained on just tokens, and they don't have necessarily or tokens for some words might be not be the whole word, and that helps. But still, the model has to. I think it's interesting how models learn this kind of thing. People are talking on the chat, but
Wait, random question: is the chat appearing on stream?
Or maybe not. Sorry, right now not. But should I put the chat on stream?
Would that be like obtrusive, or is that?
Nah, it's not. Let me just put it. I don't know. Sometimes I stream like I have my screen at full screen, and sometimes I don't. I'll just put for a moment the chat so people can. I think it makes sense if people are writing on the chat in case people want. I mean, I guess they could also just look at the chat. I don't know. Let me. For now, I'll just put it on. It's a bit annoying because the virtual machine I'm using to record is going kind of slow right now, but I'll try. Chat. Yeah, open chat. Okay, I guess I just show the current chat. Okay. So yeah, I am showing the chat right now. Okay, so Goodfire use CLTs, which are the cross layer transcoders. The study greater than mechanism GPT-2. Student attribution graph. Other innovations can be found in the circuit tracer repository. Okay. This has been started to support different kinds of transcoders. We also releasing similar. Yeah, they are okay. So there is a bunch of. Yeah, this one the one that other people were using, like the transcoders that are from Gemma that are big. There was I don't know, a few other models.
Do they say the window size for the CLT, or they just say it's a CLT?
Oh, there was a list of these for different. Oh, they have different models.
I guess it's is it like what's the window size? Because yeah, I used the per layer transcoders to make the attribution graph. I used the Quen14b, that one.
Yeah, no, this just mentioned that they released this ones. Yeah, so this also mentioned apparently, yeah, that was the thing we saw earlier, that you can just make the graphs directly on Europedia, apparently.
Yeah, that's why I'm trying to upload my graph onto Neuronpedia. I just can't figure out how to.
I'm confused. Like, this is the kind of thing that probably only works because there is not a lot of people who know about it, and probably takes a lot of compute. Well, I guess you have to log in, so maybe there is limit some stuff. I might try it later.
I couldn't get the API to work.
Yeah.
Apparently, after you make your attribution graph, you have to go to like the API, and then the thing that's been the hurdle for me is I have to make a new model on it and then make the attribution graph on it.
Yeah.
Because Quen14b is not
experienced some bugs with their API as well.
Probably,
But I hear they're
and I couldn't figure out how to use it, so that's been the main hurdle.
Yeah,
for
maybe
me
you should
uploading.
both mention it or something, because I feel like there can have been more like a few more people that aren't here. Like apart from you, there's probably only less than 10 people that have actually tried so far that are in the authors of the thing. So if you can't figure it out, it's probably most people haven't figured it out. Because you are probably most of the people trying.
And I'm glad we're talking about it.
Like my personal opinion is I think the EleutherAI one is if I could get it to work is more performative than the circuit tracer attribution graph generation since it doesn't use transformer lens.
Do you know if you can unload the EleutherAI one, like the ones from the EleutherAI also on Neuropedia?
The EleutherAI ones, I just can't figure out. There's no docs on it, so it's actually hard to tell if I'm running it correctly.
Okay.
And there's
I
a lot
guess
of
you can
different
also,
coding
for
that's-
that one, you can also just ask EleutherAI.
Yeah. I say circuit tracer is the only usable library right now. Eleuther is the documentation is non-existent unless you have a direct link to the author. You probably can't use it.
Yeah, I think it's very easy to just go to Eleuther and ask.
Yeah.
So maybe you should try that.
Well, the Neil lapse ended, so I have no reason to go try it anymore.
Don't give up.
Anyway.
Yeah, I did message Eric Ho at Goodfire about the Goodfire API thing that is probably similar or crossover with what you mentioned, and I'm waiting to hear back about that. But hoping that it gets resolved. I don't know about the Eleuther part though. I haven't tried that one at all.
Transparent support. Alright, so apparently there's a bunch of new versions of the original version of the graph thing. Alright, because the original one was freezing attention or something like that, right? I don't remember exactly what it was doing, but I remember there was something like that. I hadn't seen this one. I like this. I think it's good for this kind of posters, so you can see all of the things that people have been doing. It's kind of wild how if you kind of things go so fast in AI that you need probably some review kind of thing like this every few months, or there is no way to keep up. Okay, so there is this. There's a bunch of things by Anthropic, apparently. And we can look at some of them. Okay, so these methods are not yet reproduced on open source models. Okay, so if someone wants some Mech Interp thing to do, you can do. I guess you could implement one of these methods and make a pull request to circuit tracer or something.
I think it would be very cool to have, yes, the attended computations in circuit tracer, but I don't have the ability to do this right now. I'm like busy.
I think there are probably people who want to get into Mech Interp will be, I don't know, maybe capable of doing that and there's just missing a way of getting them to work on it. But I don't know. Limitations. Transcoder-based attribution graphs that can recapitulate some results from the other methods. Wait, visual your paper. Wait. Transcoder can shatter geometric structures in the underlying model representation of their base. What does that mean? Creative functions used to train proper replacement encourage the preservation of information, but not the preservation of geometry. Yeah, this is the kind of thing. The attribution graph analysis of the same task of intercovers through the base. Yeah, this is a thing where the model is actually doing something that has some nice geometric interpretation, like a common thing that has been seen a bunch of math things like the addition is the model is and the if you do a sparse to encoder, you get just a list of positions in that circle, for example. If in the case the circle represented the numbers, this kind of transcoder or even any of these kind of things, the whole idea of them is finding some set of discrete labels, discrete directions or whatever that represent the thing. They don't tell you anything about if there is some nice structuring the actual directions there. I don't know how you solve this without not using a completely different method. Also about the error node thing, I think out of the current methods are good enough to find out some things, but they are not very good. Like the full transcoders are not very good at, like in some absolute terms, they are not that good at constructions, and they're, I don't know how good if we had the perfect. Like the perfect reconstruction, like the perfect way of dividing the model up, how good attribution graphs will be, but maybe those also are not very good. It's kind of hard to know because we don't actually have the perfect subdivisions. I guess you could do things like manually making some model where you hard coded it and know how it works and try to see how the different methods work, although that has the problem that's probably not going to be a very natural solution or something. But yeah. Anyway, going back to this. Attribution graphs provide per product analysis using only a single example to discover the mechanisms that show what's going on in the model. Thus, they represent execution traces rather than general algorithms. Yeah, that makes sense. For example, they can show how the model computed this thing, but not directly how it computes x plus y. I guess that makes sense, but at the same time, you can probably... It does help a lot in figuring it out if you have a bunch of examples of how it works for some examples. But I get that, yeah, maybe if you want some to get some general idea of how the model works directly, you will need to do something on the weights instead of on the activations. But they have no idea how you will even do that. Not only on the weights, because then you also need to know what the kind of usually inputs the model gets is. But yeah. Similarly, you can win the steps through the model knows that the Austin capital of the state containing Dallas, but you can directly show how models store factual knowledge in general. Discoveries like trigonometric structurations of an for studying money-related problems in aggregate and extending the computation representation by the length, putting understanding of algorithms as a whole. Future work could develop methods to automate this process by merging graphs from multiple prompts. It could work. Yeah, I mean, when I reverse, with my paper, when we reverse engineer a model, what we were doing is run a bunch of lookup agents of experiments, look a bunch of things on a few samples, and then see if the same patterns show up on a lot of other examples. You kind of have, I'm not sure how you kind of have, I bet you can automate that. I don't know how you will do another method that doesn't basically work like that. Like in principle, it's probably possible to just take the weights of the model and figure out what it does directly in some way. But yeah, we are not going to do that anytime soon. Alternatively, new classes of replacement models could be trained to directly capture structured representation spaces that serve the options between multiple inputs. Yeah, that seems different thing. Yeah, something like first encoders that tells you somehow that there is some nice geometry on the activations would be nice too. Many cases are not simple to prevalent in graphs blockers from like the way people figure out the circle thing, like the ellipses and whatever, is not that they have some nice way of finding a structural model. It's just basically it's downstream of nil plotting the embeddings of a model that did modularization and realizing that it looked very like there was some nice pattern, periodic pattern, and then plotting it on the Fourier basis and seeing that it just was a few frequencies. But that's like kind of not exactly incidental, but kind of. It would be nice to have a way of finding that kind of thing out automatically. But yeah, no idea how that like. Let's go to architecture and implementation. Yeah, so this is just the Sprocket authors. Gonzalo is one of the authors from the transcoder thing. I like on the he's on the Discord, on this Discord often, and he runs the reading group sometimes. So like if someone has some doubt about transcoder or something, you can probably ask him.
Wait, sorry, can you repeat the name? I missed that.
This person, Gonzalo Paulo.
Thanks.
He's on the he's with that name on the Discord. He's from Eleuther, so he's also the Eleuther. He used to be here on the reading group most of the time, but he's been busy. Anyway, this is a bunch of Okay, so graph is the function of the graph paths related to the ending nodes to the logic nodes via feature nodes. Okay, that's how much the model requires.
Like set the pruning score so you can see how many nodes you want to look at. Threshold.
So this is basically they are testing different versions of the transcoders. Density from Okay, so this is basically saying that in this addition this measure, yeah, the cross layer transcoder, the PLDs were wait, what was this is cross layer and this is per layer, right? Or I won't misremembering the
Yeah, that's right.
okay. Okay, so the cross layers are better according to this, or at least on this setting where they are not pruning. Okay, Jan Relu is best, but more hyperparameter tuning. So top K, solid alternative makes sense. It makes sense that also makes sense to me that the top K requires less hyperparameter tuning than the Jump Relu, because on the top K you just manually saying use this amount of things, of activations, and in the other thing you rely on the sparsity penalty having some equilibrium with the some sad relationship with the laws normally, so it's going to be less straightforward. But it makes sense that it will also make work better if you figure out the correct sparsity. With this. Okay, so this is the thing with the apparently this also so this also the thing that they did this for GPT-2, but maybe other models it's slightly different. With CLTs don't perform CLTs. End-to-end fine-tuning does not improve replacement score despite reducing KLD vertex of the replacement model given by a transcoder. Okay, I'm not sure what that implies, but okay. Anyway, training time versus turning time sparsity. Training time, sparsity penetration, graph pruning, and versus achieving graph sparsity. Sending different effects too. Okay, so they took transcoders with the same architecture and varying upfront sparsity levels and paired them with varying graph pruning thresholds. For Relu CLTs, for pruning, the final level graph sparsity using pruner graphs is optimizing as it is using too much pruning. Those potential the score to be less sparse than is automatically designed and achieve the rest of the specification via graph pruning. Okay. Way to be roughly optimal, the training time should be chosen to overshoot the desired post pruning sparsity by 5 or 10 times. Okay. Okay, so yeah, CLT seem better, but not a lot better. Yeah, also, yeah, people, someone is posting, like, super stealthy ship is posting a bunch of links on the useful links for this on the chat. Which are nice. Thanks. Activation functions. Relu and Relu perform well. Yeah. So this is the kind of thing you probably shouldn't. It doesn't. There's basically saying that it's not that different. So I guess unless you probably shouldn't worry too much about the disactivation function stuff. Or like people will probably try a bunch of things, and in a few months there will be some better version that people agree on and all the libraries use or something. It surprised me. Okay, features from needs layer. Let's explore alternative or compare the global top K across all layers simultaneously. We know a number categorical calculation of per layer sparsities. Organization was 2K, well, sets of various spreadsheets across batch radio per token. Okay. There is a bunch of this is just spreading all of the different variants, I guess. Skip connections. CLTs are more computationally expensive but more extensive than PLTs. The number of features, but the way they represent models, computational cost is much. Can the advantages of CLTs capture a lower cost? Recently, other authors has explored skip transcoders, which is, yeah, it's also from the EleutherAI people and Gonzalo too. Transcoders, beta parts, compatibility. Yeah, that's the thing I was thinking, that they did the not the original transcoders, but this skip transcoders thing, and they have something where this was in February, so people were still using sparse encoders a bit. Now it feels like everyone is just switched to using transcoders. Transcoders with additional non-sparsely parallel linear connection. The use of skip connections in PLTs improves the reconstruction loss and could in principle capture some of all the various CLTs. SLT, well, PLT and the skip connections into an effective CLT where the feature in layer L can be regarded as having effective decoders in layers beyond L corresponding to your original decoder propagated through the skip connections and subsequent layers. We find that skip CLTs have lower reconstruction error than regular PLTs and some level of sparsity, but this is not translated to better replacement scores. In general, we find skip barriers on the performance of non-skip counterparts with a set of very high sparsity regimens. We believe skip connections may be transferring errors from previous layers, amplifying the input and downstream computation. Oh, I didn't know that. The reconstruction error for replacement score is possibly because the replacement score correlations only give grade to the part of the linear skip term coming from previous layers, while MSC computer calculations give grade to the linear skip, including the coming from errors. Thus, we don't consider consider skip PLTs or present a clean improvement over standard PLTs or a way to capture benefits from this. I'm curious what Gonzalo has to say about this, because he wrote this paper, the skip transcoders, Pareto dominant. Yeah, but this is person encoders, not transcoders in general. He's not here, so I guess we can ask some other time. Also, by the way, for like people are talking about CLTs on the chat if you weren't reading that. And so yeah, it's very interesting to read what they're saying. Okay, so yeah, they have a bunch of skip versions and non-skip versions. We find that while local reconstruction quality correlates with lower circuit replacement scores, different architectures can create distinct trade-off patterns within these local and global metrics. As shown in picture, there are distinct regions corresponding to different architectural variants. In particular, adding a skip connection results is a lower replacement score that a given reconstruction error. Incremental CLTs, a wet drying strategy. PLTs have more parameters than PLTs because for each layer there are many decoders and layers above it. This increase in parameters makes training CLTs more memory intensive and therefore more challenging for independent replication or local usage. Makes sense. This is why people are trying to do the skip ones or whatever to make the PLT something like PLTs but better. Incremental CLTs are a modification of CLTs that reduces memory usage by sharing weights that write to a particular layer. Okay, that makes sense. In a CLT, a feature with an encoder in a layer L writes to layer plus, the next layers and so on. In incremental CLT, a feature has an encoder and a decoder, in every layer. The activity of the feature in layer L is the cumulative sum of the activity due to each encoder and that in the previous layers. Incremental CLTs can be implemented to use the same amount of flops as PLTs with the same number of total features. We can compute the forward pass incrementally by cumulatively summing encoder contributions for features with tight decoders. This is substantial flop reduction compared to CLTs if the CLTs are not implemented using sparse kernels. Note that the memory usage for activations will still increase because we cannot incrementally perform backward passes on each individual layer and free afterwards. Yeah, sure, I didn't understand all of this, but I'm kind of tired right now. we found incremental CLTs to perform similarly to parameter matched PLTs. By parentheses, incremental CLTs with a skip connection perform better. Okay, so it's possible that while CLTs with the skip connections are bad, usually, right? Or was that PLTs with the skip connections? No, that was PLTs with the skip connections. But however, incremental CLTs with the skip connections maybe work better, but there is a they're still investigating that. We try a different variant of weight CLTs where the codec waits for the same feature are shared across layers. This variant has fewer parameters than CLTs, but does not share a benefit of flop reduction. To make it work well, we needed to include a learnable per target layer pose encoder, offsets, and scaling factors. Learnable per target layer pose encoder, offsets, and scaling factors. Okay, so they just add some bias in scaling. Even after this modification, it did not produce any symmetrical CLTs or reconstruction error on replacement scores. Yeah, I think we should. It's kind of late. We should just skip to the thing because I also don't think most people are probably like getting a lot from this part.
Yeah, I think the
In some
transcoder
ways,
stuff is pretty dense, and yeah, the future work seems nice. Yeah.
If someone is interested in transcoders, read this. Otherwise, let's just skip it, I guess. I'll look at. Okay, so self-filtering, so there's more transcoder stuff.
If you taken the input before MLP and write it after MLP, couldn't they also do it like a few MLP layers afterwards for the output, or multiple different outputs, multiple different MLP layer predictions?
Wait, is this related to my comment that I wrote?
Yeah, because if you look at the blog post you said before, I'm confused because isn't there like acausal and acausal transcoders?
Yeah, I didn't look. I actually did not look super closely at the blog post. I think with
because
the idea is with transcoders you're trying to model the MLP.
I guess it works, but it doesn't work with certain crosscoders because like if you look at the blog post on the transcoders, it's talked about the causality metric.
Yeah, I've not looked very closely at that, so I should look at it later probably. But I think the key idea is like with transcoders, like you're trying to model like the MLP, whereas with like residual stream SAEs, you're not. You're just trying to look at the latent stream itself, not how the MLP is like computing on the latent stream. Yeah, but I've got to look at that blog post because I just peeked at it and it seemed like it had good pictures that were informative.
Crosscoders, if you look at the sparse crosscoders article you shared before, if you look at the causality metric, I'm not sure if that's going to be correct for the weakly causal and the strictly causal transcoders.
Okay, I'll keep that in mind when I look at that later. Yeah, thanks for bringing that up. But
you might need to make a definition that supports the transcoder regardless of causality.
Anyway, I guess if you have finished, I'll read the direction for future work. But then someone is writing, but I guess I'll start with this. And if you want to ask something to that. In this section, we place attribution graphs and rated sequence tracing methods in context by considering next steps and possible directions for the field, opportunities for progress within this paradigm, and by exploring alternatives that use together. Yeah. There are many alternatives to policy generation, word exploring based attribution graph with different strengths and cost performance trade-offs. Training data, attribution methods, influence functions, define data and separate and responsible for the being of. Yeah, it was an old, well, it feels like very old, but it's probably like a few years old. Yeah, from 2023. The thing is something somehow really old. That's probably saying something about the AI of Mech Interp, so fast, like how fast AI Mech Interp work. They were finding some parts of the training data that most contributed to some output.
I guess we should look at the future work section now.
Yeah, this is
Yeah,
the
we're doing
future work section. Yeah. So yeah, this is just saying that you could do something. Yeah, look at something like that. Scaling the process of reading a model chain of thought. How can we analyze and evaluate the log for unexpected properties across many prompts? Oh, I didn't know this thing. It's nonsense. I guess I look at it like that. But it seems like it's some automated thing to look at chain of thought. Yes, that's it's kind of semi-arbitrary, but it feels like that's less making interpret more on the figuring behaviors part. Like both are like both as a part of a bigger field of trying to understand large language models. But yeah. Analyzing token space mechanisms, for instance, approach to identify causal relations between aspects of the model sample output, like thought answers. Yeah. This the thought answers paper. We look at that already. Linear probes can be highly effective by defining concepts and models presenting. Can we automate it and scale the process of testing many linear probes at all appropriate layer position for a given task? I mean, I guess you need still the labels, but I guess that would be nice. But is it not, I don't know, if you have some linear probe, is it not kind of trivial to just run it on all? I guess it's not at the appropriate layers, but on all layers it's just a for loop, right? I'm not sure what's the start thing you need to automate here. I guess maybe looking at have some better idea of what you want to probe or something, so you don't have the really big they spend a lot of compute trying everything. Guess maybe there is some nice methods to do some efficient approximation to doing a lot of linear probes or something without actually training all of the possible linear probes. That's maybe a thing. Instead of just brute forcing doing for each one. Like maybe you can have something like a sparse to encoder, but supervised instead of unsupervised. But I guess that's a probe with a lot of that's already just like a classifier with a lot of classes. Maybe that's better than a single classifier. It's easier to train or something than a single one or something. I don't know.
There was some work that I heard about a few months ago where someone was trying to make a big library of like probes and directions in latent space for some model. I think the person was Mikhail Velkin, but I'm not sure if I've not seen any details on this further since. It's been like a few months. But like, I think it would be cool if there were a big library of like, yeah, supervised probes, and or just like directions. Yeah, I mean, I guess like people can find them on their own too, but it'd be nice to have like a library somewhere.
It would be nice to have also a lot more examples of successful probes, or like knowing what kinds of things are seeing a lot more examples of weird things that people found on different models, to have a better idea of what kind of things you can find on models. Simple observing model behavior in response to an appropriate mix of prompts can be highly effective to infer mechanistic hypotheses, but there is an art to doing it well. What do persons here look like? Can they be automated? Yeah.
This full point seems a little weird to me. A little bit, because it sounds like you're black boxing the model, but you're trying to say that still, when it's black boxed, you can get some sort of mechanistic results.
I guess. I guess at some point, not exactly this, but I feel like when I was trying to reverse engineer a small model, there was something that I was also doing other experiments, but at some point I had some hypotheses and like evidence from trying weird prompts that my hypothesis said will give weird, like some specific result. Some weird out of distribution thing that shouldn't work, but my idea of how the model worked told me it should give the work anyway, and things like that. That I was doing something like that at some point, but I feel like I was not just asking the model directly, like just using that as the only evidence for figuring out how the model works internally. But I don't know. I do agree it's kind of weird and maybe also not super related to Mech Interp, or like kind of. Yeah, I don't know. Can we automate full hypothesis generation and validation loop with LLM agents? I mean, the answer is at some point yes, but automated hypothesis generation, can LLMs simply guess the high-level causal graphs for tasks? Can my agent make more headway related intelligently choose diverse prompts and rate the output? Maybe. I feel like when models are very good at this kind of thing, they probably also going to be good at just tell them to write the paper for you, and they can iteratively write code and do experiments and so on. Maybe there is some point where you can just tell the model, where you can get this kind of thing working, but the model doesn't just do everything. But I don't know. Like, I feel like right now, if you want a model agent to do something like that, they are going to, if they takes too long, they are going to mess up and not the kind of go crazy. Like they make some mistake, and that makes them make increasingly more mistakes because they are conditioned on the previous mistakes and so on. And when the models stop doing that, probably you can just directly get them to do the research or something. But we'll see what happens. How good are LLMs are interpreting attribution graphs, and how good can we make them with the right prompt scaffold? Maybe. I guess that this second thing is related to like having the LLM generate the what they were called, the group thing. Labels for the graph. But Automated validation. Can automated design of the probes to test from the presence of predicted features. Automated the intervention experiments and synthetic auto distribution inputs using resource validation. And you know what? How you automate this design of probes? Like, I mean, in some sense, yeah, like what's the thing you are automating? Trying different architectures or something? Yeah, I'm not sure what this specific thing looks like, but maybe there is something like that. Can we automate intervention experiments and systematic automation used for the Yeah, there is already like things like ACDC and so on. In some sense, trying to automate intervention experiments. You have something like a graph or something, and you want to test it with attribution experiments. There are some easy, there's some straightforward ways of automating that. Okay, open questions about model mechanisms. Okay, how the model always perform variable binding, tracking, and making use of information associated with a single entity. How do models aggregate information over long contexts? What state tracking algorithms are involved? Yeah. That's another thing that even with the attribution graphs and all that, we still need to. You have a model doing something like chain of thought. You still need to figure out. There was already some of this on a previous Anthropic paper, but like you have some more chain of thought level algorithms instead of on a single forward pass. And there is not a lot of research on that yet. The model is dynamically forming context representation of circuits that have not been encountered before on the training data. For those in context learning recruits pre-existing repertoire of computational motifs. This is interesting. I guess this first thing is feels like a weird way of saying it, but I guess, yeah, like it's interesting to figure out what is going on in doing context learning and what's the best way of thinking about that. To what extent is factual procedural knowledge stored in one place in the model versus being redundantly stored across multiple layers? I would expect it's the second thing, but yeah, it probably depends on like the knowledge. If it doesn't come up often, it's maybe in less places. What are the mechanisms underlying out of context learning? In what sense are the facts describing in training documents internalized by models? Yeah, I'm working on looking at this in a very toy problem, but there's probably a lot of work to do on that. Under what circumstances do models form plans or take goal direction actions? How rich complex models are represented? Do models have meta circuits that select between different possible mechanisms? What the information of the model presenting a distributed fashion is made about many context positions. Okay, attribution graphs. Okay, for attribution graphs, can we scale attribution graphs to long context? Thousands of tokens. What does those graphs look like? Are they dominated by a few token positions, or is computation spread out across many tokens? Can the process of analyzing the attribution graph completed with the supernodes identifying key pathways variating circuits with fluctuations be made more systematic or automated? Yeah, that's kind of things we talked about earlier. Attribution graph explains why a model behaved one way on a prompt, why not it didn't behave a different way? How do we identify suppressive edges that are important to the model's behavior? Oh yeah, that's interesting. Attribution graphs give a local picture of the model computation specific to one prompt. Can we merge attribution graph other ways to obtain a more global circuit picture? Curious what the link is for, but yeah, we already talked about this too. Look at this. What they were doing here. Like that. Can we learn for making attribution graphs that target quantities or general logic values, for instance, readout of linear probes or the activation of specific features? Recent works on extended attribution graphs to study attentional computations and propose several requests to follow work. Yeah, that's another thing, the attention thing. But we said earlier that that's not on circuit tracer yet, though. It seems like someone should do it, but yeah. We apply the idea of materials Kaspersky encoders to cross-layer and transcoders that they produce more interpretable features and graphs. Will you group theoretically related features than automatization? Where cross-layer connections helpful in why there's corresponding the layer model. When they cut down the number of cross-layer connections CLTs to reducing computational costs without compromising performance. For instances, by prioritizing cross-layer connections or featuring data layers, allowing them to only form a random subset of features, or starting the layer range that a feature can write to. Can LPs be decomposed into features at runtime without training a transcoder first? Which interface for the direction of the device by compute the singular variable composition of the comments on model layers. Okay, I didn't know about this either. There's a bunch of papers here that we could like look at in the. Well, maybe I would have read this one. I don't know, but maybe there's a bunch of them that we can take on feature reading books or something. Can transcoders be circumvented together by training sparsity regularized models from the start? Huh? Okay, so just instead of using transcoder, just train sparse first place. I mean, I was worried in this guy.
For this talking here, right? Remember, it was a few reading groups ago from on it.
Yeah, we read this one. Yeah, I barely remember.
I don't know which.
I don't think it was very.
It was a while ago.
I feel like I pay less attention on the authors because I don't have to be the one reading it.
Well, like one of the people who talked in our group chat ended up being in one of the circuit tracing on their own PDF.
Yeah. Yeah, this is nice, but this feels the kind of thing that unless it just happens that they work better for some reason, companies are not going to train large language models like that. I mean, maybe you can have a small, small model science kind of model too, and you can figure out interesting things from that directly. But yeah, in practice, I think we are going to need things that work on the models that people actually train for practical purpose, which is like not going to be as sparse, and the less sparsity happens to work better. Whether the advantage and disadvantage of things sparse mixtures or linear transforms in lieu of transcoders. Also don't know much about this, but okay. More stuff we can read on the future. Okay, downstream tasks. Downstream tasks for measuring and understanding. Much progress in machine learning has been driven by benchmarks, but benchmarks can be misleading or approximate what we care about in predicting understanding. What objectively verifiable downstream tasks can we create that are directly about understanding? First works includes this paper, itinerary models for killing objectives, and this other paper, which is towards eliciting licensed knowledge for LLMs with recursive interpretability. But have you read this one? Yeah, I definitely need to make like a list of papers we have already done.
One of these two papers, I think, was mentioned by Neil in the recent 80,000 hours video, I think. Probably the other one.
Maybe this one because it's by Neil.
No, it was Anthropic. I think there was some. I think this was it, maybe. But I've not actually mentioned it in the video.
Neil's like ever present in most of the papers that we use.
Yeah.
I think the takeaway was that like SAEs did really well at finding like the hidden objective here, and he's like, see, unsupervised methods can be good sometimes, but generally he's like, I think supervised methods are not given enough attention, and they should be given more attention.
Yeah, I haven't watched the interview yet, but yeah, I also got that he already wrote the the Deepmind blog posting where they already said basically that, where they were trying to find things where the unsupervised methods were better and they didn't find much. This data set. Can we create auditing games perhaps where the models will be yeah, I have thoughts about this like in the past, that it would be nice if people make something where you put some hidden behavior in a model and you release it online and make a contest or something for people have to figure out what the behavior is without just by using methods without you telling them. Amateur models hidden knowledge with fake fine-tuning and see how well our techniques elicit. How important is precision in mechanistic hypothesis? One notable consequence of the distribution graph approach for prompting is that it can find more nuances than tail hypothesis, like the addition analysis in Lindsay et al. For which kinds of downstream applications is the degree of precision important? Oh yeah, that makes sense. Like how much this whole trying to figure out how the model works in detail actually matters. Auditing games. Can we start to systematically measure the time taken for observing the novel model behavior to find the correct hypothesis for it? Can we formalize and measure this and compare the value of different tools for speeding up this process? Okay. Biology chain of thought, reasoning models. Models that use infinite computers are increasingly important, but we understand very little about them. What can we learn about the biology between DeepSeek and Quen? There will go with open weights reasoning models to study. How much can we trust the chain of thought? Where is it insufficient to answer questions about models to reasoning process? What ways can we design to flying with representative COT in automated fashion? Can we tell the difference between a model deliberately rationalizing a preconceived answer in COT versus simply being wrong, basically? Can we tell when a COT was causally important for giving its answer? Models may have causally relevant COT that gives the same answer, and editing the COT through the model of distribution, we might change the answer for unrelated reasons. Okay, that makes sense. What factors lead to different forms of unfaithful COT? I'm interested. The variation relationalize a preconceived answer. Model changes the answer because of a hint of modal beating it. Model talking logical shortcuts math problem or getting attack to claim they achieve valid proof. Yeah, that's another thing. Like the models in general wanted to give an answer and kind of cheating when they can't solve it. Models giving a reasonable chain of thought, but last minute flipping to a different final answer. Those these are for I want these are from this paper. You know, thought recently with is not our favorite. Yeah, I think I see this paper too. It's nice. Okay, so it's a bunch of plots. It's basically, yeah, it's basically it here. This is just appendix. This reading group has been pretty long, so maybe we can, like, people can just now, if you want to say something, just say whatever, and in like 5 minutes or something, if not, we don't have anything else, we just can end it here.
I'm probably good, mostly. Yeah.
Yeah, it's kind of been a long while. I didn't realize how long this has been. Yeah, it is an interesting. Yeah.
I have a question, actually. Yeah, so I'm just wondering, because I haven't been reading a lot of mechanistic interpretability papers recently, this seems like kind of like a broad overview of kind of the ideas and research. I didn't understand everything in the paper, but I was probably going to look at it more after this versus looking at future papers or other papers maybe. I don't know if you have thoughts on that, but it seemed like a good idea given that it's more of a big picture, or at least it appears to be a bigger picture sort of paper. Or perhaps you have other suggestions for other papers to get like a rapid big picture sort of idea of the area.
So I think you can look at the thing that was posted on the guy that was just posted to the chat. I don't know. I feel like this is more for people who already have read a lot of. I guess there are some papers here that this is a good place to find some papers to look at. But yeah, you should probably start with something more like the Niels guide or something. Because
Start with what? Sorry.
there is look at the chat. The first thing.
Sorry, I had to switch to my phone because my computer died. 1 second. Yeah, I think my computer's charged. Yeah. Oh, okay. Okay, cool. That's nice.
Yeah. But I feel like I think this shows a bunch of interesting things, although this specific post is more like to for people who have already seen some interpretability papers to see, like, learn what the latest developments have been like in this last few months. And it's not as focused on people who are new, like the Niels Lesbron post that was posted on the chat. Like, yeah, I feel like also talks about the details of transcoders, and I feel like it kind of assume you would know what a transcoder is already a bit. And I guess you could follow the links and read some of the papers. But if you, for example, don't know what a sparse encoder is, maybe this is not maybe the best place to get started.
Yeah,
I have a lot of papers open now. I need to watch the Neil interview later.
That's like 2 hours long, and that's part 1, and there's part 2 that came out recently that I've not watched yet.
I might just listen to it as a podcast while I'll do something else.
Too much to cover in one reading group. I think we should end soon.
Yeah, no, I was just we just ended. I wasn't going to end it here, unless I was waiting a bit in case someone wants to say something. But we were here like 2 hours, right?
Wait, what was that last World Dark? What's the part 2? Could you show me that?
Oh, if you look in the announcements channel of the server, like Neil recently did 2 interviews on 80,000 Hours podcast.
Yeah.
I think. Yeah. So part 1 was. Well, yeah, part 1 came out last week, I think.
I haven't looked at the 80,000 Hour Neil content. I only looked at the YouTube content, so maybe we could exchange info on what we learned from Fo. Not have to look at everything. There's too much.
Yeah, I mean, so it's a YouTube video. There's also apparently some. Okay, I think it's just a page for the podcast, which is probably like identical information to the YouTube video, but it's on the 80,000 Hours channel, and it's in this server's announcements channel. Like Neil posted it.
Yeah.
Okay.
Yeah, because Neil has
so much Neil content. He's everywhere. He's everywhere.
Quite prolific.
Neil is posting a lot on the announcement channel lately. I at some point I just he asked me if he could post things, and I just made a Neil Nanda role in the server for him.
Rolled. That's cool.
So yeah, I haven't been using the announcements thing myself a lot because I feel like people don't like to be mentioning with everyone unless it's really important. But yeah, something I like the use Neil has been doing. Anyway, let's just end this here. Unless someone was going to say something, but yeah, it's been a long while. I'm also kind of tired, so let's just stop.
Yeah, sounds good. Thanks for hosting. This is nice. Yeah, I think it was nice because like some of the like papers that they reference, you like had familiarity with them, so you kind of gestured towards them a bit, and that was nice for me because I'm kind of new still. But yes,
yeah,
thanks. And
I also have no idea about a lot of the transcoder stuff. I probably should have skipped it more, but yeah.
I haven't tried training transcoders yet because I'm not sure if I have the compute to do so. So I haven't tested actually doing it.
I think it's very intensive.